Alright, welcome to day 3 everyone of the 2019 Advent of Code. Today's question has been posted, and real quick before I begin, I just wanted to first say I have seen the video and I've noticed that it gets a little hard to see the text of it, so I have increased the text size on my IntelliJ area here, and then I've also increased the bitrate on the video, so hopefully you should be able to see the code much more clearly. So to quickly sum up what today's problem is, the problem is that there are two wires that are connected via a central point and then expand outwards on a predefined path that the input file says or specifies. So given the input file here, we have to use this, read it in, construct the wire pairs, and then figure out where the wires cross. Obviously, they'll probably cross in more than one location. Then, given all the intersections, we need to figure out which intersection of the two wires is the closest using Manhattan distance, which is different than normal distance. Basically, instead of drawing a straight line from the origin to the intersection, we will be simply subtracting the Cartesian coordinates, and that's how you get the distance there. Either way, the problem is simple enough. However, actually doing it will be a little more difficult. I am going to go for the more quick and dirty route. I'm sure there are many more efficient, elegant solutions to this. However, this just came to me the quickest, and that's what we're going to go for. So to start this out, we of course are going to read in the file just like every other day so far. So this will be just the inputs. I'll set it equal to file util and load the file res day3-1.txt. Alright, so we will go ahead and quickly import list. There we go. So I read it in. So now let's deal with the first wire. The first wire, we're not going to deal with crosses at all. We're just going to deal with loading it in. The way I'm going to load it in and store it is I'm going to go ahead and create a class down here called point. And basically we're just going to use points as a way to, I guess, hold where the wires have been going to. So let me quickly create a constructor for point to make it a little bit easier for us to manage this. So we just need an X and Y coordinate that will be given from the input here. We'll keep track of where we are via the instructions. So by the way, the instructions of the inputs basically tell you up, down, left, right, and then how much the wire is going. So if we start at 0, 0, the first instruction would be write 1005. So we go from 0, 0 to 1005, 0. That wire would extend that length. So we will be simply keeping track of the points that this goes through. So we'll keep track of all the points 1, 0, 2, 0, 3, 0, all the way up to 1005, 0. Again, this is not efficient in any stretch of the imagination, but it's quick and dirty and it works. Or will work, I guess. I haven't done this yet. So real quickly though, we've created a class point. It'll hold an X and Y coordinates. However, I know that this will come up in the future. Okay, that was weird. I know we will need this in the future. So I'm gonna go ahead and add it now. We are going to need to override the equals method of this class. That way I will be adding the points to a list here. So we'll call this visited points. So I have this array, or I have this list here of all the points that we have gone through with the wire, or the first wire. And in order for when we check the second one to know if we visited the point that's in this wire, I'm going to make our job easy, or make our lives easier, and override the current equals method of point. That way we can just ask the list, does it contain this point? And it will do the logic for us because it will automatically call this method. That's just how Java works when it compares to objects. It'll use this method. So I'll just put that override. IntelliJ is being very weird with override. I will first check that the object that we are checking it's equal against is an instance of this point class. This is just making sure that we have a point and that we're not checking if this point is equal to 1. That's just a simple check here. If the object is not an instance of point, simply just return false. Just don't even bother going on. All right, so outside of this, we will first check. We actually will just return then. We will cast the point. We'll go ahead and cast this object as a point. That way we can access the x and y, and we will return simply point.x equals x and point.y equals y. If those two are equal, then the points are at the same point location. If they're not equal, they are not, and from there. So pretty self-explanatory logic there. So first, let's load the input in, and now let's grab the first wire, string wire 1. This will be our input and the first line, because there's 2 lines. This is the first wire, this is the second wire, and that's how the input file is structured. So grab the first wire, and we will go ahead and actually I'm just going to do it here. Grab it and then split it on commas, because that is how the instructions are split. All right. So now we have the wire, we have each of the instructions. Let's just do a quick for loop over each of the instructions. And wire 1. Wire 1, not L. There. All right, so now we have a for loop here. So each instruction will start with either a R, U, L, or D. So we will quickly do char. Actually, let's do a switch statement here, and we'll do it on instruction.char at point 0. And the first case is let's do up first. And copy this 4 more times. Up, down, right, left. Default isn't really needed. Just kind of ignore it, so I won't include the default. So for up, we will do that. So let me also grab the integer. So int distance is going to be equal to integer parseInt instruction substring from 1 on. This is how far, so we are substringing from 1 on. If you don't know, substring takes in a starting ending position. If you omit the ending position, it's just a starting to the end. Strings, their indexes start at 0, so this R would be index 0. This is index 1, 2, 3, 4. And so we're going to start at 1, which is this one here, and then go to the end, which would be that. So we will get the number 1005, parse it, and this save it as our distance. So given each of the cases, so for up, we are going, or for each of the cases, we will be doing a for loop to add all the points in. So int I equals 0, while I is less than distance, I plus plus. However, they're going to vary in that up will go up in coordinates, down will go down, right and left, as you would think. We do need to keep track of our current point. Actually, I'm just going to do it as this, int x, int cx, and cy, current x, current y. Instead of a point, just because it makes it a little bit easier. Meh. Now let's just do a point, just to keep it all the same. Current point. Might as well keep it all the same. All right, so current point. Let me also make a constructor here that will take in a point. Real quick, because I know I'll need this. All right. So to start it off, current point will be equal to the new, actually let's just do current point down here equals new point, and we will set this, needs to be static rather than a method. Set this equal to 0, 0. So start at 0, 0. So as we go up, we will simply set current point equal, or current point dot y will increment, and then we will add a new point and give it current point, and this will be how we know we visited a point. Pretty simple there. Down will be the same thing, however we will go down instead of up. Right will be, instead of x will be, or instead of y will be increasing the x, and left, instead of increasing the x, we will decrease the x. And there we go. A little bit of redundant code, but either way it's fine. It's not a huge deal. Again, quick and dirty. So this should put all the visited points for the first wire into our list here. So now the next bit here is to do this again, but for the second wire. And as we go, keep track of which points we have seen, and then calculate how far from the origin they are. So good. So we're going to go ahead and do this again. Actually, I'm just going to go ahead and copy this entire for loop. Go for wire 1. Distance is all the same. Good. So the only difference here is that current point will start here. We will do a for loop. However, before we add the new point to our visited points, what we're going to do is first do a check on visited points dot contains point. If it does, we will do some logic. If it doesn't, we are going to add it. And again, each of these statements here will kind of follow the exact same path. All right, so good. And yeah, so if the visited points contains our current point, what we are going to do is we need to get the distance from the origin, which will be 0, 0. So the distance will actually be pretty easy for us to do, because with Manhattan distance, it is simply the Cartesian coordinates subtracted. So the distance, I believe, will just be x plus y. So let's do int current shortest distance, current shortest dist. Let's set it to start to integer max int, and point current closest intersection. It's really long. And I'll start it at null. I guess doesn't need to be necessarily two variables, but either way. So if it is that, we will go ahead and calculate the distance will be equal to point.x plus point.y. I'll make sure I spell Manhattan right. And then we will go ahead and do a quick check. If our Manhattan distance is less than the current shortest distance, replace current shortest distance with our Manhattan distance, and replace the current closest intersection with our current point. There we go. All right, so now let's go ahead and copy this to all of these. Again, this would probably benefit if you had like a direction method that would automatically do this logic here for you. you wouldn't then need these 4 cases to all be exactly the same, but just slightly different. But again, I'm not worried about that at the moment. I guess I can clean that up here in a second once I do that, or once I finish this off. Okay. So now we are good. We have gone through this for loop, and now after this for loop executes, we should have our point. So we want them in hand distance from the central point to the closest intersection. So we are then going to do a system.out.println print line of our closest or current shortest distance. So I guess we actually don't need this point at all. So I'll go ahead and remove it. Doesn't do us any good. All right, there we go. Save it. What was this error? I can be created local. It's fine. All right, so let's give that a run. And let's see if we get an error or if we get a response. We get a response of that. Enter as the right answer. And sadly, it is not the right answer. It is too high. Okay. Let me go through and check my code real quick. Oh, you know what? I'm running the wrong day. You know what would help? All right, so I just realized I'm running the wrong day. So you know what would help is actually run today's code instead of yesterday's code. Let it run. It's taken a while. I feel like it either is using up a lot of memory or it's hit an infinite loops. No, it's not hit an infinite loop, or else it would have terminated. I feel like my just very inefficient method is just not the best. There we go. Wow, that's okay. So let's try. That's gonna be way too high. All right. All right, let's improve this a bit. So we are going to improve this. First, I'm going to improve this by taking all this code and moving it out of the main method. And putting it into here. And from here, we'll simply call new day 3. All right. So now we don't need the whole static bits here. Okay. So current position can be moved to be local. That is fine by me. Visited points as well. All right. Let me now add a method called offsets. So public void offset point. And from there, we can copy this code into it. Actually, this is where having current position be global would be fine. So we're actually going to undo that, put current point back there, and put this here. So distance will be a parameter, and actually we will quickly do a char direction, and we are actually going to be moving this into here. So we're kind of relocating where our switch statement is. Our switch statement will instead be right here. Sort of. Actually, let's not use a switch statement. Well, you can just use an if statement. So if direction equals up, down, left, right, So down is minus minus, left is x plus plus, and right is actually right's x plus plus, left is x minus minus. All right, there we go. So now we can just use this offset point instead of this giant switch statement. Offset it by a distance with instruction.char at 0. Cool. And then for this bit here, we'll add another method. Same thing as offset point, but we'll call it, whoops, offset point with check. And we'll have it return an integer. And let's just steal this one's code. Paste it here. Replace what this code is with that. And now we can remove this. Okay. So for this one, it's going to be returning something. We have current shortest distance. Well, we are actually going to have this go away. This will be done where we call it. So we will be calling it from here. So we'll be calling this dot offset with check, distance, and then the char, which is instruction char at 0 with our distance. And then we will be getting distance here, or we're getting Manhattan distance from here. We will be storing current shortest here. We need to check if Manhattan distance does not equal -1, because I'm going to return a -1 if it's not, if it shouldn't update, or if it's not any closer. So go ahead and remove all of this code, condensing this down a lot. So with a check, so we will here return this bit. Condense this down a bit, and then else we'll just return -1, not there, return it out here. And this will represent the fact that it is not visited, or none of the points, or if this line does not intersect with any other line currently, it will return -1 to say there's no intersections here. And we're actually going to do an absolute with these points because Manhattan distance does not care about negatives. So we will be doing some absolutes. Okay. Now that that's all done, let's give this a run, see what we get. I'm going to run some debug mode actually real quick. To see when we get to each for loop. Just out of curiosity. So how long does this first one take? Oh, shit, I should have started it before. There we go. All right, how long does this first for loop take? Not long. How long does the second for loop take? Probably really long. Second one takes really long. Okay. And it's probably to do with the fact that we're checking if valid points contains. Okay. All right. Actually, that ran much quicker. I'm curious. Okay. So let's run this again. We should get something much quicker than we did last time. Maybe. Maybe not. Oh, we got something. Okay. Let's see if that's our answer. It is not the right answer. Our answer is still too high. Okay. So let's make sure. So current y plus plus down. Left is minus minus. Right is plus plus. Up, down, left, right. That all looks correct to me. Trying to see if I see any reason why that wouldn't be right. Distance is... Oh, we're returning. Oh, well, there's our issue. Okay, so here's my issue here, is that we're returning here. Okay. Closest. We do need to have a small check here. And closest, intersection. We do need this. Turn closest intersection. So if closest intersection equals that, or closest intersection, let's do int Manhattan distance. Well, there's our issue. Okay, and then we do closest intersection equals that. Good. And then no return. All right, now let's see if that fixes our issue. That gives us 6. That is correct. Okay. Let's reset to what our numbers should be. No longer need to output this. All right. Get a new number here in just a second. Our solution is very inefficient. That list gets really big and it does not like how big that list is of points. Get that as our answer. Let's, fingers crossed, let it be right, and it is right. Goodness. All right, so the issue we were having there was that we were returning whenever we got one intersection, and we need to not do that because we still need to verify all the points and correctly move our current point to the correct location before returning. That was our issue. On to part 2. Okay, so for part 2, we have the same problem of crossing wires. However, instead of finding the closest intersection, we want to find the fastest intersection, in that if we travel from our origin out with each point being one step, we want to find where the first intersection occurs that has the least amount of steps. So, given that, what our code isn't really going to be helpful here. So we will use this as a base. However, we will keep this and do, we'll change this to with distance check and with step check. And then, so for our step check, we want int steps. So we only want the first, intersection. Not necessarily. We just want the number of steps to each intersection. Okay. So if we want the number of steps to each intersection, the issue is we're going to have to return each step. So we're going to have to do a list. And then this is step intersections is a new array list. Actually, this is going to have to be a map, because we need to do a point and then steps. Well. Alright, int steps are int point with enter the number of steps it takes to get there. There we go, import it. And this will be a hash map. Alright. So here, so if it is visited, we will do steps and we will put and in distance and steps will be the running total steps. And so we will put the current point with steps plus I. That will suffice for there, and we will simply just return steps intersections. Okay. So then up here, so we also need to keep track of the steps for here. So we have a list of points. I want to do, instead of a list of points, let's do a hash map of points and steps. So actually, it's gonna be a map, not a hash map, but there. And then visited points. When we use it, we'll be doing a put. We need a step here, and it'll be new point with steps plus I. Very simple there. And this will be contains key. And again, contains key. And here we will do steps. So we need to keep track of our step count. So int steps will start at 0. Pass steps in. And then increment steps by the distance we've gone. And then same thing down here. So we have our distance, we have this first check. So now we need our second check. So this is a map of points and an integer. And this is step intersections. And then this will be simply equal to this dot offset with step check. Pass this through. Reset steps equal to 0. Pass steps through as well. After we're done, increment steps by the distance, and good. So now we have our map of intersections. So we need to do one more for loop on each point in here. This is going to really just make a huge hit on our performance, but our performance is already terrible, so it doesn't really matter. The key set, and then for each point in our intersection, we're going to calculate the steps. We need to hold our current shortest steps. Same thing, set it equal to the max integer starts. We are going to have to then do calculate the steps needed. Steps sum will be equal to the step intersection getting our points plus our visited points, with at the given points. That'll be our step sum. We will do a quick check like we just did here. If our step sum is less than our current steps shortest, we replace it and we should be good there. So this will be our first. So this is going to be the closest Manhattan distance. And then this will be the least steps one. Give that a run. Let's see how slowly it runs. but we should still see 6 don't. Okay. Because that's actually the max integer. All right. What is happening here? Okay, so one thing at the change is that because we're using a hash map, it actually doesn't use this equals method. It actually uses the hash code method. It's an int, right? Int. It's actually that, yeah. So it actually returns a hash code. So we need our hash code. And what we're gonna do is for our hash code, let's just do x times 10,000 plus y. That should be unique hash codes. And run this again. Not quite. Okay, so we're getting all points, and I just realized that we were checking for this, but we weren't creating a new point here. So this could be the reason why we're getting a null pointer. And in fact, that is the reason why. However, that is not the correct Manhattan distance. It isn't what we had before. So let me comment this out and try and figure out why our Manhattan distance has changed. Okay, so our Manhattan distance is the same there. Okay. By the way, that should be equivalent steps. Okay, so our Manhattan distance is correct there. So then when we uncomment this, it changes from 1626 to something else higher. Okay, so there is our issue. Somehow this code is changing our Manhattan distance? Wait a minute, what? How is that code changing the Manhattan distance? It's actually making it closer, which doesn't quite make sense. $16.26. So if I just do this line, does it still? Okay, this line here breaks it. So something in offset here triggers something. I just did new hash map and commented the rest of it out. Does it still do it? No. So literally something in here is messing things up, which is really weird. Oh, we're not right. Current point's already been addressed. Right. Right. Okay, we need to store the current point. Okay. I see the issue. Point, current point, cache. I gotcha. Right. I don't know if this will work. Will this fix it? Okay, we get that as our least steps. That's definitely not right. No. Oh, answer is too low. Okay. I don't think changing this to be a new point will work. Will make a difference either. But there we go. Okay. So that solves our current point issue. Let's see. So least steps is too low. And are we adding? We are currently adding the steps correctly. Let me check against what the examples are. So this should be 610 steps. 608. We might just be off by 2 because of counting errors or counting differences. If we're off by 2, again, it's just because we're off by 2. Or wait, okay, we're off by 2. It's probably because we're starting at 0 when we should be starting at 1. Let me reset this back to ours. All right, we start the count at 1 instead. We probably get the right answer. No. Oh, we need to start both steps at 1. My bad. Okay, let me now try to submit the second answer. And we got it. Wow, okay. That took a lot longer than I thought. It wasn't too difficult in the end. It was just a lot of kind of Java be finicky with remembering how things work. But we got it in the end. So, I don't know how much the recording's been going on for an hour. Good. I got a lot to edit. Alright, so to summarize what we did. As always, we loaded our input in. We split it based upon the actual specific instructions, which are here. Based on those instructions for the first wire, we went through every point that it visited. We added it to a list up here, along with how many steps it took for the second part to get there. And then we go to the second wire. As we step through the second wire, we calculate where we find intersections. For the first part, we find the intersection, and then we find the closest intersection. And the second part, we find the intersection that took the least amount of steps to get to. And in the end, the code is a lot better than it was going to be. However, it is still very inefficient and probably not the best solution. But again, we got there in the end. Hopefully you guys enjoyed. Hopefully tomorrow goes a lot better than today did. But I will see you guys all tomorrow. Peace out.